Up to now, we've been looking at states of deformation and loading where we have one very dominant stress. So, for example, we have a single normal stress, or we have a single shear stress that dominates the behavior of the system. And when we want to talk about failure criteria for such systems, we've been typically thinking about yield of metallic systems, and we'd say, for example, that the normal stress has to be less than or equal to the yield stress in tension, and that would be, for example, this first criteria here. And then we've also looked at the case where we have yield and shear when we have shear-dominated systems. Now, of course, we've also seen a couple of cases where we have multiple types of stresses at the same time, so both normal and shear, or multiple normal stresses and things of that nature. And that situation is what is known as multi-axis loading, or multi-axial stress states. And I'd like to talk about failure criteria, or in particular yield criteria, for these types of states of stress. So the question is, what about the general case? So suppose I have a stress I've written in two dimensions. Say I have two normal stresses and two shear stresses, or one shear stress really, because we know we have symmetry of the shear. So in other words, sigma yx equals sigma xy always for moment equilibrium. What can we do in this type of situation? How do we decide whether the system is going to yield or not? Now, one possibility is just simply to apply our criteria for single states of stress and apply them one by one to each component of the stress tensor. So I could say sigma xx has to be less than the yield stress, sigma yy has to be less than the yield stress, and sigma xy has to be less than the yield stress, this time in shear. There are a couple of defects with this way of doing things. Number one, it's going to give you relatively poor results. It doesn't match experimental data. Number two, if you think about it, this way of applying the criteria really depends on the coordinate system that I've used to describe the stress tensor. So if I rotate the coordinate system, I'm going to end up with different normal stresses and different shear stresses, and then the criteria are going to change to determine yield. And we don't want that situation. We really want to have a situation where we take a state of stress and we can evaluate some function, and it tells us whether the system is going to yield or not. And so the thing that we're really after is some type of function of the stress tensor as an entity in itself is going to be less than or equal to some critical value. And basically here we have a single criteria, which is really convenient also. So that's really the goal, and we want the system or this function to be independent of whatever coordinate system we decide to express the components of the stress tensor in. So this is the goal, and what we're going to do is we're going to focus on two very popular criteria. One is known as Tresca's criteria, and the other one is the Henke-von-Mies criteria. And these are both fall into this category of functions that we can evaluate on the stress tensor and check against some type of critical value. And both they give slightly different predictions, but they both do a relatively good job, and they have advantages and disadvantages that we'll discuss.